Now for this given set of inequalities, let's think about how to draw its graph. First, notice that usually your x and y are bigger or equal to 0. That means you'll only be working on the first quadrant. So let's think about this corner right here as 0, 0. And for the moment being, we'll think about each of the boxes to be 1. So this would be 5, 10, 15, 20, 25, and 30. So this is actually 30 by 30. Hopefully it's going to fit. All right. Then we go for each of these inequalities, and we're going to draw the graph one by one. First, x plus 4y less or equal to 48, but you first want to just draw the equation first. Then after that, you can figure out which side is this inequality really. Now, since we all know that linear optimization only gives you lines, you're always going to be drawing the graph by just figuring out 2 points on this line. Since if you have 2 points, there's only one line connecting it. Just finding 2 points is your goal in order to draw this equation. The simplest one is to just see what you get if you plug in 0. If you plug in 0, you get 0 plus 4y equals to 48, which means 4y is 48. And you divide both sides by 4. And 48 divided by 4 is 12. So y is equal to 12. So that means 0, 12 is a point on this line. So let's do that. When x is 0 and y is 12 all the way here, it should be a point on the line. Okay, anything that satisfies is a point on the line. Then another option would be just to set y as 0. Remember that this is the way you find x and y intercepts, right? So that's an easy way to draw the graph of a line. When you plug in y as 0, you get x plus 0 equals to 48. So x is just 48. That's really simple. However, there's something I don't like. This only goes up till 30, so 48 is way over there. So hoping that the actual graph doesn't have to go that far, we'll just not draw this one. Rather, well, since x only goes up till 30, let's just plug in x equal to 30 and see what we get. When x is 30, that means 30 plus 4y is 48. And when you subtract 30 both sides, 48 minus 30 is 18. So 4y would be 18. Divide both sides by 4. And you get y as 18 over 4. And if you punch this into your calculator, you'll see that this is 4.5. Alright, so you have 4.5 right here. Okay, then you just connect these two. That will be your first line. So here's the line that you drew out of the first calculation. But we're still not done yet because, see, this is an inequality. We only drew the equality. When you have an inequality, that means either above the line or below the line. And to determine which way is the correct one, you just use a test point. And in many cases, you just use 0, 0. That will tell you whether it's the right side or the wrong side. Sometimes 0, 0 happens to be on the line itself. Then 0, 0 is not good for figuring out which side is the inequality shading. In that case, you have to use 1, 0 or 0, 1 to figure it out. Okay, so let's plug in 0, 0 here. So if you plug in here, if you plug in 0 into x and also 0 into y, that will be 0 plus 4 times 0, which is a 0. And that is indeed 48, indeed less or equal to 48. So that's a check. That means the area containing this point will be the shaded region for this inequality. So we know that it must be this side that the equation is shading. Okay, the inequality shades this side. All right, let's carry on. You have 3x plus 4y equals to 64. Once again, you just write down the equation, and you plug in 0 for x, and you get 4y equals to 64. Divide by 4 both sides. And when you use a calculator to do 64 divided by 4, you're going to get 16. So 0, 16 is a point on this second inequality. So 0, 16 is right here. Okay, now if you plug in 0 for y, you get 3x equals to 64. If you put y equal to 0. And I don't like this because if you actually divide, you're going to get like some decimals with 3333 or 6666. So this is not good. So instead, let's just plug in maybe y equal to 1. Right? Yeah. Let's trial and error. Okay, so if you plug in y equal to 1, you get 3x plus 4 times 1 equals to 64. Subtract 4, this is 4, so subtract 4 both sides, and you get 3x equals to 60. Perfect. Now that if you divide by 3, you get x equals to 60 divided by 3, which is 20. So when y is 1 and x is 20, that's a point on the line. So let's go to x equals to 20 and y is 1. This point right here, that's another point of this second line. And here I connected the two, and we have the line for the second inequality. Still, you have to plug in 0 and 0. If you plug in 0, 0, you get 0 on the left side, and less or equals to 64. And yes, indeed, this works, and therefore, this second inequality is this region here. Right. Actually, let me use a different colored pen to shade that area. Okay. Now let's move on to the third inequality, this one. And it's 4x plus 2y equals to 62. And then when you plug in x equal to 0, you get 2y equals to 62. So y is equal to 31. That's like slightly above, so I guess we can still use it. Let's just say this is 31. And then if you have 4x plus, again, I mean, you could use y as 0, but you end up dividing 62 by 4. That's okay. That's okay too. Yeah, let's do that. Yeah. Or you could put y as 1. That will give you a better number. Okay, so you have this, and you have x would be, so if you set y as 0, you get 4x plus 2 times 0 equals to 62. And dividing by 4, you get 62 over 4. And using a calculator, you'll see that this is 15.5, which is 15.5, this point right here. And now let's connect the two to get the line. There it is. And now let's plug in 0, 0 into the equation, inequality on the left side. 4 times 0 is 0, 2 times 0 is 0, 0 plus 0 is 0, and 0 is indeed less or equal to 62. That means when this line divides the entire plane into either that side or this side, the one that contains the 0, 0 is the one that you should be shading. So let's just shade this portion. Okay. So now that you have shaded all the region, think about where is the place where all of these are overlapping. Because the overlapping place is what we call the region of feasibility. So the overlapping region would be right here. Right here. My pen is not exact, so it's a little misleading. Hopefully you don't misstate what I'm saying. So it's really this point here, and this one, and this one. This is the region of feasibility. Feasibility region. And that's it. That's how you draw the graph.